Good evening, good afternoon. To start with, I want to ask the audience, how many of you have used ChatGPT in a social setting? You went to a party in the evening? Yes, I see a few hands. Yes. That's a very low number. I thought it would be fun and games. A lot of people do this in the evenings. But that's how it started, right? In October, November, December of this year, when we had ChatGPT come out of the blue and explode in the marketplace, the first things everybody did was, wow, it can answer questions that I can think of, that I don't have to really structure the question and have 22 sequence questions laid out, and I can get answers. And of course, a lot of fun things you can do. Have it write poetry. I used to ask ChatGPT to write something to thank my host for the dinner they served me. So that was always entertaining. So that's how this whole thing started. But AI is not new. And what I'm going to talk today about is what I see happening with AI in general, with the ChatGPT and the large language models coming into the picture. So I'm Krishna Tammana. I'm the CTO of Gupshup. We are a conversational AI company. We are right in the middle of the storm of everything generative AI. And I've been working with AI systems since about 2012, mostly with traditional systems, leveraging open source AI systems in the beginning and writing our own models. We always had developers do Java coding and Scala coding to come up with complex models that suit the workloads and the problems we are solving. But coming to Gen AI, last December at Gupshup, one single day, we stopped traditional AI completely. So we had AI work streams in BFSI verticals and e-commerce and a couple of other areas we were playing with AI, but more traditional AI. But once we saw what was happening with Gen AI, we completely stopped and switched over to Gen AI as the base model. And I'll talk a little bit about why we did that and whether that's the end-all, be-all. So what we realized is for our workloads and for our problem space, what Gen AI does is profoundly useful. So let me step back a little bit and talk about what the mechanics of Gen AI are. And oh, by the way, how many of you have used Gen AI in an enterprise setting? Can I see a show of hands? Good. There is some acceptance and some experimentation going on. So in an enterprise setting, it's very different than what we could do when we go to a social party and ask questions. Any questions you can ask in a social setting are probably going to get good answers from Gen AI, but enterprise is a little bit different. And we'll talk about that as well. First and foremost, the way Gen AI works, as you all probably know, if not, just let's take a second and talk about that. It's simply a matter of taking very, very large amount of data, pumping it into models, making the system understand the language and the context you're asking questions in, and have the system generate one word at a time, literally one word at a time, by looking at all the connections and learning that was done, because we ingested billions of parameters and data into the system. So when you have a system that's generating the answer one word at a time, but because it's looking at a very, very vast amount of data, the accuracy of that is fairly high. If the volume of data that it was dealing with is limited, your answers will be just as precise or imprecise. So what really changed is the ability to ingest and process very, very large amounts of data. Billions of parameters are packed into these large language models. That's why we get the answers we get. So, does this mean this Gen AI system is sentient? Does anybody believe it is a sentient system? I don't think so. It's a system that's very powerful, can ingest a lot of data and give answers because of the context and the processing it has done. Is it intelligent? Yeah, probably. Depending on your definition of intelligence, you could say it's an intelligent system. I don't think of it that way because I'm a technologist. I think of exactly what is going on behind. There's no premeditated action that I would call intelligence. So with that background, what I want to talk about is what we are seeing today in Gen AI and how to put it to use and where I see it going into the future. Today, to put a Gen AI in use, and let's talk about enterprise specifically, what we have to do is take a large language model. There are many available right now. Some are paid, some are free. You have to start with one of those models and then ingest the data that is relevant to your enterprise and give it your context first. And there are several ways of doing it. But once you ingest that data, then you have to train and tune the system. This tuning and training are methods. It's not absolutely new to AI, but the way we do the tuning and training today with Gen AI is very, very different. For instance, in the past, anytime you had to train these algorithms, you have data and then you tweak and tune the algorithms too. But now, with Gen AI, with things like prompt engineering, which is basically giving a number of prompts to the AI system and telling it how to process those prompts and seeing the results. The more prompts you give, the better tuning you can do. So if you imagine the skill set required today to take a problem and apply AI to it is more of prompt engineering than bringing a Java developer or a Scala developer and then cleaning all the data and pushing all the data in, then doing the training and tuning on that set of data. So what happened and what's happening is that the skill set required today to tune and put an AI system to use is significantly changed. You don't need a computer science degree to get this started. So one of the panelists in the previous session said, you have to think slightly differently to think of all the things that could potentially go wrong and then use prompts. This can be done by humans without computer science background. And that, I think, is a very big fundamental shift and change in how AI systems were and Gen AI-based AI systems are right now. In fact, I saw an advertisement that said the highest paid job right now, just out of college, is that of a prompt engineer, not a computer science engineer anymore. We'll see how long that lasts, but at least that's the need of the hour, and that's where that demand is. Now, prompt engineering in itself is not sufficient all the time to get the high-quality answers you want from your AI system. There are other techniques like embeddings that are allowed in the Gen AI systems that make your answers more precise and better. So after training, depending on the amount of training and the accuracy of training, you get results accordingly. But as we were talking, if you were in the previous session, we were also talking about what's called hallucination. Basically, when you have the entire internet ingested into one model, and you ask a question, even if you tuned it, Sometimes when the AI system cannot figure out exactly what the answer is, it can go off and search the rest of the universe of data it has ingested and processed and learned. So suddenly you'll find answers that are completely irrelevant. That's what is called hallucination. So when you're using AI systems, to put them to use properly, you have to do prompt engineering to tune it, and you have to use embeddings potentially to make the answers a little more precise and not allow the system to hallucinate. In an enterprise world, hallucination, what we are finding, is almost never acceptable. Enterprises want their customers to get very precise, accurate answers without confusing the customer. Hallucination is not acceptable, but Gen AI systems, it's not that easy to eliminate hallucination completely. There are ways to do it by tuning the system, but if you tune it too much, you will get the exact answers as you would get from an FAQ. You won't get as intelligent answers with the connections and the context that you would want, which is a high value of the Gen AI-based system. So what this really means is that you have to strike that balance where you can give answers with very high fidelity through the tuning process, but also leave enough room for it to be intelligent. So this is where the systems are today, where it takes a while to get the system ready for a production environment, because all the validations you have to do it by hand. You have to think of all the questions potentially your customers could ask, and then continue the tuning process till you are satisfied. And there's always a possibility that you didn't correct it. But the one good thing about AI systems today, the Gen AI systems, is there are mechanisms to train on the go. So as soon as you have an answer that is not accurate, you could use what is called a teach mode to teach the AI system that the answer you gave is not right. Please correct it so that in the future, this does not happen. So there are many techniques right now that are fundamentally changing how we can leverage AI systems to solve many problems. So let's ask the question, so Gen AI, is that the end-all be-all, or are there problems that we cannot solve with Gen AI? What Gen AI is really good at is understanding language, understanding your question, including the semantics, and responding using a very, very large amount of knowledge that it has accumulated and has been trained on. But there are classes of problems that are still not under the purview of Gen AI because they're not language specific. For instance, if you have analytics type of problems, you have a vast amount of data, numbers, and you want to ask questions about that, a complex question about that number. How many customers from one particular region have the propensity to buy this product during Diwali at 4 p.m.? That is a combination of many things that requires data to be crunched based on past buying habits, the economic status of that particular region you're talking about, the people in that region. There are any number of things that go into analyzing data to answer those kind of questions. So those are not necessarily the best workloads or the problems to give Gen AI at this time. Though you will find that there are inroads being made in Gen AI to solve some of these problems, but what I characterize it as pretty lightweight at this point. There is a lot of research being done in the database world, in the data world in general, where all these analytics used to happen and continue to happen, to see how they can merge set theory in the data structures with Gen AI. It's still not clear if that will be something that will eventually merge under one umbrella, or will it stay as a separate field for a long time to come. So this will be very interesting to watch. But for now, Gen AI is very good at some things, and the traditional AI is very good for something else. So including things like, if you want to find patterns in your data, clustering algorithms, et cetera, they're still very, very valid. Those have been done for a very long time. They'll continue to be done. Deep learning is still, neural network-based deep learning is still a valid thing for certain problem space as well. So with all this progress in Gen AI and the amount of work it takes to get output and results from AI systems with Gen AI has fundamentally changed. And what are the implications of that? First, let's talk a little bit about issues that are common before and now. You know, algorithms and data, algorithms are only as good as the data you train them on. Garbage in is garbage out. So that doesn't change with Gen AI. If you put 7 billion parameters or 30 billion parameters of garbage, you will get garbage. So that doesn't change. So there is a lot of work to do in the future to figure out how much of the modeling that we are doing is high quality, high fidelity data, and how much of that is not. And it's very, very complicated to figure out. The second thing we were talking a little bit earlier as well is explainable AI. You know, explainable AI is not a new thing either. In the past also, we've been talking about explainable AI because when an AI system gives you an answer and somebody asks, how did you make that decision? How did you come up with that? It's not easy. Some algorithm somewhere learned something based on data it saw and then concluded this particular answer or made a recommendation. How do you trace that all the way back is not a trivial thing, and that was a problem with traditional AI as well. This one just makes that much more complex. It doesn't eliminate that. So I think there's a lot of work to do to understand these kind of things. So your workload really matters. So where you use AI really matters. If you're using things in making decisions that impact lives of people, and if it's not explainable, it's going to be a challenge. I think these are things that we'll have to deal with as a society. It goes well beyond just technology, because the implications are on people. So between explainable AI and ethical AI is the other topic. Bias is ingrained in data. We're humans, we're all biased. The data we have generated and created is biased. And so are the algorithms and the models that are trained using biased people with biased data. So bias is a big thing. And again, not new with Gen AI. It's something that we've been dealing with and we will continue to deal with. I think it just got that much more complex. Now, these are all things for us to solve over the next few years. So in many ways, Gen AI, we are in the very early stages. I would say we're in the early innings. If you think of a sports analogy, it's a very, very early innings, and there's a lot to come. Of course, there's a lot of hype. Everybody wants to do it. Everybody wants to build resumes based on that, et cetera. All good, but we will go through the traditional hype cycle, and I fully expect that we'll come out of it because this is a technology that is here to stay. It's not going away. Let me talk a little bit about where I see this evolution happening. So by the way, you know, some of what we learned is because we had to learn the hard way and end up at a place where we had to build our own LLMs. So what we ended up doing is that we took foundational LLMs and customize them for our domains and our workloads and our use cases. And that allows us also to host those LLMs and models in our data centers, because data residency is a problem for many, many enterprises. So we were forced to kind of solve that problem, which ended up being a good thing. We learned a lot about what it takes to do this. So what we see happening right now is, anybody owns NVIDIA stock? No? There you go. Lucky man. So if you see what has transpired, the computational power required to process these large language models and train them and repeatedly train them, insane amount of compute power needed. NVIDIA has a 2-year backlog for chips right now. There's so much demand. It's crazy. I think that is not going to subside anytime soon, but there is a lot of work being done to make changes in how much effort it takes to train these models and change the computational framework itself. So first and foremost, a lot of open source models are out. In the last 7 months, 8 months, it's incredible how many open source models have come out. And I think that'll continue to be the case. And there's a lot of work being done to see how to reduce the footprint of hardware requirements to train these models. So there is ambitious goal set to train models in a very, very short interval on commercial hardware, not requiring special GPUs like the NVIDIAs of the world. That's going to be, I think, a very, very big change. And the research and investment going on right now will help change that profile completely. While we increase the number of parameters we process and make the system smarter, we're also going to try and make it cheaper as an industry. The other thing is, if you're familiar with most of the compute resources today, they are all floating point number-based systems. Floating point number-based systems are fairly expensive compared to integer processing. So there is another effort to use integer-based processing systems to reduce the amount of energy you have to employ to train these models. And again, fundamentally changes computational models. There's already research going on in this, and the results are very, very promising already. So there is a tremendous amount of research and work going on in this entire space, purely on the computational side, not just models and tuning. It's just sheer hardware required. Earlier in the session, there was a question about green AI. I think the AI has taken us on the non-green side immediately because of the amount of computational required. I mean, people are just spending insane amount of money to put large data centers to crunch very, very large amounts of data. If you just take the hyperscalers between Google, Amazon, Google, Microsoft, itself, I think it's a line item on their books right now on how much they're spending on AI-related compute. It's that big. So between research in hardware that is required and necessary and the explosion of data and the parameters, I think we will take 2-3 years before we can really meaningfully talk about the impact of AI on being green data centers, et cetera. I think that's another one. And one more thought on where we think we are going, which is edge computing. For the kind of data that we process and what is required to bring very meaningful answers using Gen AI to life, everything happening on in the data center is impractical for certain workloads. There is a lot of demand for edge computing and decision-making at the edge using Gen AI. And there is plenty of research going on there to see how we can miniaturize these models. Again, a topic that came up a little bit earlier, to push the necessary compute. Obviously, it can be very huge, but just enough compute to the edge so that the decision-making doesn't have to do a round trip to the server. So that's another area of research that's happening. And I think fundamentally all of these will change what's happening today in the Gen AI. So that's why I say we are in a very, very early innings of what Gen AI is doing. What's, I think, most exciting, if you're a technologist, is what could potentially happen with Gen AI and traditional AI and the workloads in the traditional AI combining together. So we don't know the answers, but it's fascinating to think about what is possible there. But from a social context, everything we discussed about the implications of AI, whether it's autonomous vehicles or any other system that is powered by AI of any sort, applies to Gen AI as well. That doesn't go away. So I think we are in for a wonderful ride. If you think that you can wait to figure anything out, it's probably changed by the time you decide to figure something out. The amount of change we have seen in the last 7-8 months is incredible. I can't keep up with it, and I do this for a living. So with that thought, with the tremendous excitement and some degree of nervousness, I will pause here, and I think we have 4 minutes to answer any questions that come up.